Good evening, engineer.
Okay, it's starting. Good evening, Doc. So we're going to discuss today about maxima minima. Now, maxima minima is an application of what we have discussed in differentiation and in getting the derivatives of certain values. Now, ito yung parang isa sa mga pinaka-peak, okay, na topic ng differential calculus, application of the formulas we have learned as we have from the time we started. Okay, so first problem is I'll be solving it and then kind of follow my solution, Josh. Okay, so the first problem states that a farmer has enough money to build a 100-meter fence. What are the dimensions of the field he can enclose with it with a maximum area? So we are given only a 100 meters of fence. So I think yun lang kaya ng budget. So yun lang ang kaya niyang gawin. Okay, so let's start by illustrating the problem. So let's say this is the fence. You have your dimensions of x and y, or your length and your width. Okay, so we are given a perimeter, which is yung length ng y, which is equal to 100 meters. So the perimeter, the formula for our perimeter is twice the length, or twice x, plus twice the width. Okay, in this case, 2y. Okay, so on the perimeter, we will be taking, or we will isolate one variable. It's either x or y. You can select. Now, I'll be selecting, let's say, y. Okay, so meaning 2y is equal to p minus 2x. Okay, and then isolating y, we have y is equal to p minus 2x all over 2. Okay. Now, we have a given perimeter which is equal to 100 meters. So your P here is equal to 100 meters. Now, we substitute the value of P, the perimeter, in this equation. So we get Y is equal to 100 minus 2x all over 2. Okay. So therefore, your Y now is equal to 50 minus 2x. So we have the value for Y. Now, we are looking for, I'll just go back
50
to the problem.
minus divided
We
by
are
2 yata.
going for the maximum area. Okay, so we are looking for the maximum area. Therefore, is it still visible here, Josh?
Opo.
Visible.
Well, okay, so it's quite small na po dito. Okay, so
Di ba,
our
di ba
area
po,
now,
di ba po dapat po y equals 550 minus x lang po?
sorry. Thank you, Josh, for that. Minus x. Okay, so 50 minus x. Sorry about that. Okay, dividing 2 by 2. Thank you. Okay, so is equal to area now is equal to your length times width, which is x times y. Okay, substituting the value of y in the equation for area. Area now is equal to your x multiplied by quantity 50 minus x. Okay, we distribute x. So area now is equal to 50 x minus x squared. So meron tayong dalawang variables lang, which is yung x mo and your y. So we get the derivative of a with respect to x. So your dA dx now is equal to 50x is equal to just 50. Derivative is equal to 50. And then minus 2x. Okay. So for the critical point, dA dx reaches 0. So this will become 0. So 0 is equal to 50 minus x. Therefore, 2x is equal to 50. So x is equal to 25. So your length now is equal to x. Now, substituting this in the given value, this one, y is equal to 50 minus x. So your y now is equal to 50 minus 25. Therefore, our y now is equal to 25. So therefore, the dimensions are 25 and 25. So our length is 25 and our width is 25, meaning we constructed actually a square. So 25, 25, 25, and 25. So that is equal to 100 meters. Okay, now to check if it is the maximum, we're going to test it using the second derivative. Now, as we know, getting the second derivative, if the value is less than 0, it is the maximum value. If it is greater than 0, it is the minimum value. Okay, so maybe I could erase this part, the illustration. Okay, now our dA, this one, or RA prime, since we're going to get the second derivative, RA prime is equal to 50 minus 2x. So 50 minus. Now, getting the second derivative, or A double prime, so derivative of 50 is equal to 0, and then minus 2. Therefore, our second derivative is equal to negative 2, wherein negative 2 is less than 0. So, it is a maximum value. So, I repeat, if the value is greater than 0, then it is the minimum value. If it's less than 0, sorry, it is the maximum value. So, testing the first derivative, taking the second derivative, we get the value of negative 2. So therefore, we are sure that our answer is correct. It is a maximum value.
Opo.
Okay, Josh, the solution clear? Okay. So there's another problem. I think it's the same process as this one, but it's only given 3 sides. Could we see the problem? Okay, so rectangular lot is bound by a river at the back. Okay, so 3 sides na. But still, there's a condition. Okay, there's a 24 feet, okay, space in front. Okay, so you may start, Josh. Illustrate the problem first.
Sa ba? Wala. Kaya ganun.
Opening is 24 feet.
modify.
Show the steps, ha?
Na-modify siya. Pwede
Show,
na.
pakita mo yung ano, yung sa taas yun. Show the area of the
Hindi
perimeter.
Siya, hindi siya ganun talaga.
Yes, okay. Okay.
Okay, so the front costs 150 pesos. That is only x minus 24. And the sides cost 100 pesos. simplifying it.
Next page.
1.5x. Josh, could you simplify further? Y is equal to 336 divided by 2. Could you simplify it further so it's easier to differentiate?
6 over 2, 168.
Yes, okay. And 0.75. So that won't be a fraction anymore. Okay. Josh, do it dx. Derivative of a with respect to x. Just did this one because it's double derivative, second derivative.
Your 5. Can you fix your 5? Looks like an S. Make it like this. Unit.
Wait lang.
X is equal to 125 feet. Okay, so what is the
Dimensions, yan.
largest lot? Okay, so the dimensions are 112 over, and 84 feet. Okay. So just could you compute for the area? So what is the maximum area that we got from the two values, the two dimensions of x and y? Although it's not actually required in the problem, but could be, maybe we will solve for it. Okay, so the largest area, largest lot that can be enclosed with that 300 pesos with a 24 feet entrance is 9,408 square feet. Okay, very good, Josh.
Very
So
good.
let us look at the third problem. Okay, now this time with this rectangular field to be enclosed by a fence and divided into 3 lots. Okay, by fences parallel to one of the sides. Find the dimensions of the largest field and its area. Okay, so we're looking for dimensions and its and the area that can be enclosed with the given of 800 feet of fencing. Okay, technology naman, Josh.
Yes.
Easy to draw. I think you're getting better in estimating distances and areas. I think they're almost equal. the three lots you have drawn are almost equal.
Ayun na po.
So 3 lots, they are divided.
Dimensions 800 feet. Okay, so
Josh, don't cut. Do not cut the solution. Cross multiply the 2 first. Okay, so divided by 2. Y is equal to 800. So 800 minus 4x. No, that's correct. We're just lacking one step of the solution. Okay.
You can use the expression.
Negative 2x squared plus 400. Josh, you're missing out. On the right side na lang. Show us how you got 100, the value of 100. Okay. Okay. Could you prove it, Josh, that those values are correct, if we would add them, you could get a value of 800 from the perimeter. If 800 is equal to 800 from the perimeter. Okay. Okay, so yes, 400.
Put the units, huh?
Is 20,000 square feet. Wait, are we looking for? Did you go back to the problem, Josh? Are we looking for the area also,
Opo.
or just the dimension? Also for the area. Okay, so the maximum area is 20,000 feet. Okay, and then we have proved that the total fencing is also equal to 800 feet. So your y or your length is 200 times 2, and the 4 partitions are equal to 100 feet. So that's equal to 400. Therefore, summation of 800 feet. Okay, very good, Josh. The next problem, is it still a fencing problem? No. Okay, it's much complicated. Okay, so box will be built with a square base. Okay, so the length and width are equal with an open top. Material for the base costs 8 pesos per square foot, while material for the sides costs 2 pesos per square foot. Okay, find the dimensions of the box and the maximum volume of its the maximum volume. I think it's redundant. Okay, and the maximum volume that can be built for 2,400 pesos. I think naulit yata yung natin maximum volume. Okay, so ayan. Back to drawing the box. Okay, how would you construct the box?
Yan ko lang box niya. Ano.
Okay.
Ano.
Yes, okay. So it's an open top.
Technology, engineer.
Oh, ano kay?
Hahaha.
Kay Josh naman ang ano. So same length and width. pesos per square foot for the sides and 8 for the base. Hey Josh, where did you get the value of 300 again?
Hindi ko sila
Bring it down first.
Hahaha.
Technology.
I know you could compute it that easily, but you could show us the solution.
Nagbalit ka rin.
Okay. Josh, could you insert it above the volume? Above the volume. V is equal to x squared y. Could you insert above? Just write above.
Yan na po.
Okay? So just write V is equal to length times width times height. For us to know where you got the formula of x squared y above the V. Okay, just above that. Yes. Okay. So that we know where you got that value of x squared y.
Can use the next page.
Even without the radical sign, I think it's clear. Okay, so solving for y.
Units.
Josh,
Units.
y is equal to, wait, back. Second page. Okay. Besides y is equal to 30 minus 10. Okay, just write it. Just beside the y. Okay. Y is equal to, okay. So next, what is the maximum volume? Okay, it's still 20, so no, it's 2,000 cubic feet. Okay, is this the last, how many problems are there?
6 problems.
Okay, number 5.
Haha.
Number 5. So a box is to be constructed from a piece of cardboard 20 by 20 inches by cutting equals. Okay, it's an interesting problem. Squares from each corner and turning up the cardboard from the sides. What is the maximum volume of the largest box that can be constructed? Okay. Just could you move it a little bit to the left so you can draw the box at the right side? So that's the plain sheet. Okay, that's the cardboard to be cut. Then on the right side, let's see if we could draw the box that is to be constructed. Iba yung method niya sa paggawa ng box. Yung mga small line kasi yung big lines.
Yeah, wala na nagturo sa kanya yung mga yan.
Oo nga, Doc. Pagkaan.
Actually, meron.
Pero kaya, Doc, at least pati yung illustration, sa illustration pa lang, magigets muna yung problem.
Oo nga eh.
Kaya kailangan maganda yung ano. But you know, Josh, siguro madali dyan, gawa ka nung dalawang rectangle na lang, tapos pag anoin mo, isang rectangle at isang rectangle. Tapos,
Pero paano po maalam kung square?
okay, actually, hindi natin alam talaga siya, di ba? Malalam pa lang natin dahil parang the illustration is an estimate of the problem. You don't know any values pa eh. So then you would correct yung given that illustration dahil sa mga values na nakuha natin.
Saka hindi, given din.
You're not really sure talaga sa illustration.
20,
Yan.
Ala, kapal. Ala, gosh.
May madaling may ano dyan. Oh. Oh. There's a function called undo.
Yes.
Patay.
Sabi nga lang si Josh na dito.
20 inches. Yes.
Long to sa.
Oops, sobra. On this side.
Wait.
20.
Josh, could you move that 20 inches on the right side a little bit more to the right so you can show the measurement of the 20 minus 2x? So that it would fit in the figure.
Bali. Oh.
Ha? Oh, sige.
Already na lang. Clear, didinig mo kami?
Opo, yes doc, maliwanag. Ay, nawala.
Okay na.
Hello, doc, doc. Yan, okay doc.
A wise man once said, when in doubt, use line 2.
Tama. Okay. What is the largest maximum pala? Sorry, what is the maximum volume? Okay. I think from the figure, mas makuha natin yung solution na agad. From the figure pala. Josh, use another page. Use another page so we can see the factoring.
Factoring.
Okay, so V, okay, 0 is equal to 400, no. Okay. Yan. Josh, go back on the first page. Go back on the first page. So, K12. Okay, sige, good. You arranged it in proper order. Okay, continue. So, and then, lowest term.
Lang.
How did it become?
Divide mo na.
Okay. Then 0 is equal to what? Quantity. Okay. So we need to show them that part in algebra, the factoring part. Okay. So the values for x are, one value of x is equal to 10, and 1 is 10 over 3. Now 10 cannot be
5.
Okay. So the answer is 3 over, sorry, 10 over 3. Are we looking for the maximum volume?
Yes, I think.
Yes.
Okay, could we substitute it, Josh? So it is, no, V is equal to, okay. $592.500. It is in cubic inches. Okay. So I think we solved, and finally, rectangular container. Okay, now this is quite long. I think it's longer than the previous problem. A rectangular container with a base length, okay, twice its width is to be made with 48 square meters of metal, including the lid. So it's fully covered. Find the volume in terms of X and find X for the maximum volume. Okay, so meaning we're going to replace the height with X. Okay, Stacey. You may illustrate it first, Josh. Rectangular container. Now the base has a length, twice its width. Wait, what are you trying to do? Okay. So that's the length.
What's the width?
So, wait lang. Ano ka sa left? Ay, sa mata ko lumilipad. Okay, wait lang.
Samia.
May pumasok na ano? Nick, engineer.
Parang Doc, yung maliit na. Wait.
Nignik.
Close ko lang eyes ko, Doc. Palalampasin ko lang sandali. Parang, why eh? Ano nakapasok dito naman?
Wow. Minecraft na indoor.
Sinipon ako ng oras.
Surface area.
Next time. Okay. So, Josh, you could add. They have common variables.
So what's mo na sa ano?
So, Josh, kindly write the value first. Kindly write the value of y before the volume. Bring the volume down. Write the value of y in that second page, so I could distinguish if it's correct. Write the value of y in the first page. The value of y. Copy it and then could you paste it that value?
Pwede po.
Y is equal to, okay.
Yan.
Okay. So that's the first unknown. Right? Could you go back to the problem, Josh? Could you go back to the first problem? Josh, go back to the first page. So, find the volume in terms of x. So kindly, yeah, you could box that or encircle that. That's the first unknown. in the problem. Okay, that's the first unknown. So we're looking for the volume in terms of x. So your volume now is equal to 16 minus 4/3 x squared. Okay, now next is the maximum volume. Negative. Okay, is that the maximum volume?
Differential.
Okay, solving for the value of x, Josh.
Ano po yan? 16. Tapos mawala. 4 over 3.
Okay.
What is L length mo?
Okay, let's do it again, Josh.
That's the
Okay, let's do it again. Okay, no. Your formula is correct. Your formula is correct. Go to the second page. Go to the second page.
Second page.
Okay. So now we're going to
Invert mo.
wait. There's no more x here in the denominator.
Give L.
You cancel x into x squared. See, your solution is again lacking. So there's still, okay, there's no more x in the 3x in the denominator. You cancel the x with the 2x squared in your first, in the upper part. See, there's no more x. Okay, so now it's only 48x minus 4x squared over, sorry, 4x cubed over 3. Okay, now we can solve for the value of x. 16x, okay, minus, I think it's cube, 4x cubed. Okay, 8 over, so 4/3, okay, that is 12. Okay. Josh, don't cut the solution, Josh. Don't cut the solution. 12. Okay, over 3. Okay, that's better. Okay, then canceling 3. That's why you're getting mistakes in the solution. Okay, so now, okay, is equal to 16. X is equal to 4, or x is equal to positive and negative 2. Okay, so that's the value of x. Now, what is the maximum volume?
Di ba pwedeng negative?
Okay, so negative cannot be used. So we're going to use positive 2.
Meters.
So now what is the maximum volume?
It's for the maximum volume. Ayun na pala. Ha? Wala na.
Hey, where's the solution, Josh? Okay, so now what is the maximum volume? Substituting x.
Wait na pala.
Wait, Josh, you have to substitute the value of x first in y. Where are you? Okay, okay, that is the one. Okay, so volume is equal to 16 multiplied by 2, okay, minus 4/3. That is equal to 32 minus Okay. Josh, what's that? It's 64/3 cubic meters and or equal to or congruent to.
Approximately 20.
Approximately. So it's cubic meters, Josh. It's in cubic meters. 21.3 cubic meters. Yeah, that's right. Approximately. Yeah, cubic meters. Okay. Is that our last problem?
Yes.
Okay, it's the sixth problem. Okay, so I think you've mastered solving maximum minimum problems in with rectangular. Okay, pertaining to rectangular worded problems. Okay, so I think we'll continue next time with cylindrical or circular problems in maximum minimum. Okay, I think that's all. I hope to see you again next time, Josh. Okay, so see you again. Goodbye for now.
Thank you po.
Thank you then.